find the total resistance across AB using star delta transformation. So student 1, you have to understand that when we are using star delta transformation, it also includes series and parallel elements. So then we'll always have a doubt, where do we start, how do we, from which corner do we start, right? So let's see all those doubts and clarify it. But before going to star delta, one has to be clear with series and parallel circuits. Step 1, before we go to step 1, so always many of us will have a doubt, where and how do we start. So I'll give you three methods. I'll give you three steps. First, always check for any series element in each steps, right? And then check for any parallel elements. And then if the circuit is not consisting of series and parallel, then you have to analyze or inspect for star and delta elements. Now let us check. Step 1 is to check if you have any series elements. So there are no elements in series here, right? If your answer is yes, 4 and 4 are in series, so you can see there's a connection which will be just like your metro coaches, or just like people standing in a queue, right? Just one after the other, or like your friends who are sitting in a bench side by side. So you can see this 4 and this 4, right? It's a connection here, right? And this 8 and this 6 is again not in series because we have a connection here, and 4 is also connected. Now for example, let us say 8 and 6, right, we're connected with this 4, and the other end of this 4 is open, which is hanging just like your incomplete flyover. Then only we can say that 6 and 8 are in series, right? Because we will be neglecting this 4. So right now there are no elements in series. Then let's check, do you have any elements in parallel, right? So what's your answer? Before I comment, what's your answer, right? Just write down somewhere your answer so that we can discuss later if you have any doubts. But my answer for this is none of the elements are in parallel to here, right? So please observe, as we have told, parallel, it should be there between two elements or more than two elements when we have common between two ends. So 4, let us say this 4, and if you say, for example, someone is saying that sir, this 4 and 8 is in parallel, I would say no. How? 4 has two ends, this end at C and D. Similarly, 8 also has two ends at C and E. But for 4 and 8, C is common. But you can see 4 other end is D and 8 other end is E, and it's obvious that D and E both are not same, they are different. Thus, they are not in parallel. So what about this 4 and 8? Again, 8 and 4, they share a common end here, the common wall. But 8 end is D, 4 other end is E, and thus they are not parallel, right? So then we have to inspect now for any series and parallel elements, right? We have done that, so we have come to a conclusion that there is no element in series and parallel. Then we have to inspect for star and delta connections. So let us see all the elements in star, and right, so how do we know it's a star? So we have to have a junction of 3 branches, right? I hope you have seen the previous video where I've explained now about star delta and the formulas and shortcut to apply. All those things will not be done in this video, so please see the previous video first before seeing this video. So this 4, 6 and 8 is one of your star, right? So this 4, 6 and 8 is your star. You can see this junction has 3 connections, 4, 6 and 8, thus this is star. And star always has 4 ends, 1, 2, 3 and 4 ends, right? So this is your first star, this is your second star, 6, 8 and 4, and this is your other star, 4, 4 and 8. Again you can see there are 4 ends, 1, 2, 3 and 4, right? So these are all only the star elements present in this in the given circuits. Now let us see all the delta connected elements, right? So delta has 3 ends again, so you can see your 8, 6 and 4 is your delta, right? So this is one end, this is the second end, and this is your third end, right? And we have only one more delta, that is the other way, 4, 6 and 8. So now we have seen that which all elements are connected in star and delta, but how do we start, right? So let us solve here. Step 1, arbitrarily you can choose either from star or delta. So I have shown you 1, 2, 3 elements were connected in star and 2 elements were connected in delta. So you can choose any one of your choice. So I'll be showing 2 ways of solving the same problem in 2 different ways, so you can understand clearly. You can start anywhere, correct? That's your freedom. So I'll be using this 4, 8 and 6. You can see here I'll be using this 4, 8 and 6, which is connected in star. So I'll be converting this star to delta. So concentrate on the black elements when you are converting from star to delta. So it has 3 ends. As I told you, it has 4 ends. Right? There is 1, 2, 3 and 4. Right now I don't require 4. But when you're converting vice versa, that is delta to star, we require 4 ends. So connect end to end, that is 1 to 2 as the element as A, 2 to 3 as its element as B, 3 to 1 or 1 to 3 as its element C. So 4, 6 and 8. I repeat, 4, 6 and 8 are star and its equivalent delta are A, B and C. So apply formula as discussed in the previous video. The formula for A would be, any guesses? You can write down. I'll just you can pause the video, or else then you can write down the formula for A, B and C and then check and then verify. So right, I'll tell you, I'll again repeat here. A, right, the ends of A are connected between 1 and 2. Between 1 and 2, the black elements are 4 and 6. So the formula for A would be 4 into 6 divided by 8 plus 4 plus 6. Right, so A is equal to 4 into 6 divided by 8 plus 4 plus 6, and the answer is 13. And similarly, when I do it for B, it is B ends are connected between 2 and 3. The black elements are 8 and 6. So it would be 8 into 6 divided by 1, which is not connected, is 4 plus 8 plus 6. Right? And the common mistake which any student does is, most of the time, they would divide the whole by 4. Right? So this is not divided by it's not dividing the whole by 4. It's only for the product you are dividing, not for your summation. And similarly, C would be 4 into 8 by 6 4 into 8 divided by 6 plus 4 plus 8, and you get the answer as 17.33 ohms. Right? What we have done, we have converted the equivalent star to its equivalent delta. That is, the equivalent 4, 6, 8 are divided amongst delta as 13, 26 and 17.33 ohms. Then how do we relay the circuit? So then once you have converted star to delta, I repeat, you have converted star to delta. What is required now? Delta. What do you do with star? You just eliminate them. Right? You can see in this diagram, you just eliminate those star. This is how we are reducing the element from star to delta. Hope you have understood now about step 1. So let us recap what we have done. Always whenever you are analyzing the circuit for R equivalent, irrespective they mention whether you have to use star delta or not, or only series parallel, it's your duty to check 3 steps. Check if they are in series or not, then check if they are in parallel, then if they are not in series and parallel, then you have to apply either star to delta or delta to star. That's left to you. Right? That's what we have done now. We have arbitrarily we have selected 4, 6 and 8 as the star element that we have utilized and converted to delta. Once you have converted to delta, erase those star. So similarly, if you are using, we'll see in the next step, we'll do it vice versa. We'll select any one delta and array and then converting it to star. Step 2. So this is what we have done in step 1. Now how do we start? It's again same. Check for any series element. Check for any parallel element. If they are not there, then inspect for star and delta. So what do you think? Are there any elements in series? What's your answer? Right? You can pause the video. You can write down somewhere you think this is in series or this is right or in parallel. I would say none of the elements are in series. Then you check for any parallel. Now pause the video and then analyze. What do you think? Are there any elements in parallel? Right? Now I would say yes. There are 2 elements as such in parallel, which are those 13 and 8. These 2 are parallel. How can we say that these 2 are parallel? Between 1 and 2 they share common boundaries. Thus we can say that they are parallel. Right? Next, 26 and 4. We can say they are still parallel because they share common boundaries between 2 and 3. Now here we are not going to use star delta because we know that these elements are in parallel. Thus it's not necessary to apply star delta. Now we've applied only once. So sometimes in a problem you might apply star delta only once. Sometimes you may have to apply 2 times, sometimes you may apply all the times. It depends on the circuit. I hope you know how to convert the parallel element. It is 13 into 8 by 13 plus 8, 26 into 4 by 26 plus 4. You get the answer as 4.952 and 3.467. So now we have converted the parallel elements, right? Then what do we do? Step 3. From this you have to apply step 3. Again inspect if they are in series, parallel or star delta. So what's your answer? Any element in series, right? Yes, you're correct. We have 4.952 and 3.467 are in series, right? That's your step 3, and the solution is 8.419. I'm just skipping step 4, and again I'm asking you to start again to analyze, to check if there are any element in series. As I told, after each conversion, again start from scratch, check if they are in series. If not, then check for parallel. If they are in parallel, do it, and then again start, check whether they are in series or parallel, and then so on. If they're not in series and not in parallel, what you have to do? You have to apply, you have to arbitrarily choose either star to delta or delta to star transformation. Now here none of the elements are in series, so then we will check. This is your fourth step. I remember this is your fourth step. I'm not adding one more here. Then check if they're in parallel. What's your answer? Right? You want to think? Pause the video and think before I discuss the solution. Yes, these two are in parallel, so we will not be going for the third step. It is 5.6666, and it's very easy here. 4 and 5.66 are just like your metro coach, right? It's connected to one of the other, or just like 4 ohms is standing in front of 5.66, and they are in series, and the answer is 9.66 ohms, right? Now the same problem, right, we'll start analyzing by convert what we have done last time. Last time we have converted from star to delta. If you remember, we have utilized 4, 8, 6, converted this star to delta, and then we've got the answer as 9.66. Now what we'll do is we'll use this delta or this delta. We'll see either of these two deltas we'll utilize to solve for delta to star transformation. Remember, this is important. You can't apply delta to star at both places simultaneously, because you can use these three elements only once. Now see, for example, if you are applying this delta 8, 6 and 4 and 4, 6 and 8 to converting from delta to star, you can do it individually but not simultaneously, because you cannot use the 6 ohm twice. So when you're using 8, 6 and 4, you're utilizing the 6. Simultaneously you cannot apply delta to star at this area, right? Because you're using, because 6 is already used by these two elements, right? I hope you understood. So how do we start? Again, check for any series, check for any parallel, and then if they are not, then you have to utilize star to delta or delta to star transformation. So now, as we know, these are the answers. Let us increase the size of the circuit so it will be easy for you to visualize. So I'll be using the top 4, 6 and 8 to converting from star to delta, right? So here we are converting delta to star. Earlier we have utilized 4, 6 and 8, which is in star to delta, right? So as I told, now we'll be having 4 points. Whenever you are utilizing from delta to star, you will have 4 points, right? So let us name them as 1, 2, 3, and I hope you are aware what is this called. This is called as neutral, N, right? Let's connect them. Let us name them as A, B and C. Step 1, we have to calculate the formula for A, B and C. So here we have, so as I told you, it's your freedom to select. First time I've shown you 4, 6 and 8. Now for the same sum I've shown you the other 4, 6 and 8 which are converted in delta. So concentrate on the green color elements, right? The formula for A is, now A, in the previous video I hope you have understood how do we use a shortcut to solve. So A is connected between which of green elements? 4 and 8. So the formula is 4 into A divided by 4 plus 8 plus 6, right? And the answer is 1.778. and similarly for B and similarly for C, right? So once you have done, what will be doing, right? So you can see, if you have doubt, how come this, how can this 4, 8 and 6 are in delta, right? You can also rewrite this circuit in this way, right? And you can see we have to convert this delta to star. How? From this end one from this end, and one from this end. So this is A, this is B, and this is C, right? So once you've converted delta to star, what do? You remove those delta elements and retain the star elements. Right? You can see we've converted 468, which is in delta to star. So remove those delta and retain those star elements, that is A, B, and C. Right? Now we'll replace with its respective values, and it's important also replace A with A only. Do not again shuffle with A to B and B to C and C to A. Right? Yeah, I've done it correctly. Then what do? Step 1 is done, right? So this is step 1. What do we do for step 2? Again, start from the scratch. Analyze for series. If they are not there, then for parallel. If they are not there, then start delta. So what do you think? Any elements in series? Just pause the video and think. I repeat, I've asked any element. I've not asked any one. What's your answer? Are there only one? Are there only two? How many elements are in series actually? So pause the video, write down somewhere so that you not change your options, right? Then you can discuss later. These two elements are in series. These two elements are in series. These two elements are in series. Just like your metro coach or your train, right? Or just like two people are sitting one beside the other. So these three, we can do it in the step 2. We can do all these together because we're checking all the series elements. So the solution is here, right? Now step 3, I repeat, this is step 3. What do? You again check for any elements are in series or parallel. The answer will be no, and then you will check if the any elements in parallel, and the answer for that would be yes. We have some elements in parallel. I repeat, this is your step 3, but I'm showing this in step 2 itself. So these two are in parallel. I hope you know the formula. 9.33 into 6.667 whole divided by 9.33 plus 6.667. You get the answer as 3.888. Right? So two branches will be reduced to one branch. Right? Then again this is step 5. Step 4, you'll check any elements in series. Your answer is yes, and then that's your answer, which is same as your previous method, as 9.666 ohms. Right? So as discussed, you can start either from star to delta or delta to star. So before going to your, I'll be posting one more video. So before going to the next video, I want you to go through this problem once again and understand this better, to understand those problems much better.